Hi all, welcome to Ally. Today we are going to discuss a problem in engineering mechanics 6.7 a K Tayal book. So in this problem it is given that a block of 1000 kilonewton is to be raised against a surface inclined at 60 degree. You can see in the figure. So a 15-degree wedge which is placed here and a force P is acting on it, and the coefficient of friction is given that 0.2. So we want to find the force P such that which will just start the block move. If the coefficient of friction between the surface of contact is 0.2, yeah, we want to find the force P such that the block just start to move. Yeah, let's move to the solution. First of all, we want to isolate the blocks. I'm isolating these blocks 1 and 2 here. So I am numbering the contact surfaces as 1, 2, and 3. So first of all, we want to draw the free body diagram of the wedge. First of all, a normal reaction acts from the ground, that is N1, and the force P acting on it is P. And obviously, when a force P is acting towards left hand side, so there is a friction between the ground and the wedge, which will act towards the right hand side as F1, which can be also represented as mu N1. And the contact surface between the block and the wedge, there is a normal reaction N2, and when the block moves towards the right hand side, so there is a friction along the surface which is an inclination of 15 degree, so there is a friction, that is F2. Okay, similarly for the block weight 1000 newton, a weight of 1000 newton acting downwards, and the normal reaction which is at this contact surface, and there is a friction F2, and from this surface there is a normal reaction. I have represented this as N3, and when the block will move towards upward side, so there is a friction on the downward side, so that is F3. So we can draw the free body diagram of these two figures like this. First we can consider the wedge. So n1 in the upward direction, we can represent it here, and the force P towards left hand side, that is here, and the frictional force F1 is towards here, and we can represent it as mu n1, and the frictional force F2 here, which is making an angle 15 degree with the horizontal, so we can mark the 15 degree here, and the normal reaction n3, sorry, n2, which is making an angle 50 degree. I can explain you that, because let us consider an horizontal, so it will be 15 degree. Okay, now we can create the equations. P is equal to mu n1 plus mu n2 cos 15 plus n2 sin 15. This one, this is along the summation of fx equal to 0 and summation of fy equal to 0. We will get this equation. So n1 plus mu n2 sin 15 is equal to n2 cos 15. This is the second equation. Now let's move to the block, the free body diagram of the block. So from this figure we can draw the free body diagram. So a force of 1000 Newton is acting downwards, and N2, F2, F3, and N3. So N2 is making an angle of 15 degree. Similarly from here, and N3 making an angle of 16 degree with the horizontal. 60 degree with the horizontal. Now we can write the equations: summation of fx equal to 0 and summation of fy equal to 0. So the component of n2 in the horizontal direction is n2 sine 15 degree, and f2 can be the component of f2 along the horizontal direction is mu. F2 can represent as mu n cos 15 degree, which can be equal to n3 sine 60. This is n3 and the horizontal component is sine 60, n3 sine 60, and f3 can be represented as mu n3 and the horizontal component is mu n3 cos 60, and the along the y directions we will get 1000 Newton towards the one side, 1000 Newton, uh, plus f3 and represent as mu n3, and this horizontal, sorry, the vertical component is sine 60. So this is, and from this mu n2 sine 15 degree will be the vertical component, and n3 cos 60 will be in the upward direction, and n2 cos 15 this one. So we have created these equations of. Now we can solve this equation. Now we are solving this equation. P is equal to mu is given, that's 0.2 and 1 plus I am take common n2 and 0.2 into cos 15 plus sin 15. So while calculating we will get this P is equal to 0.2 and 1 plus 0.45 to n2. So we want to calculate P, so we want n1 and n2. So from the equation 2 we will get a relation between n1 and n2. n1 is equal to n2 into cos 15 minus mu sin 15. Mu is 0.2. So n1 is equal to 0.914 n2. This is the second equation. Sorry, sixth equation. So now moving to the third equation n3, which is here. We can rearrange this equation in terms of n2 and n3. We will get a relation between n2 and n3. So n2 sin 15 plus mu cos 15 is equal to n3 into sin 60 plus mu cos 60. So while calculating this, 0.452 n2 is equal to 0.966 n3. Similarly, we can go for equation number 4. Rearranging this equation 4, we will get a relation between n2 and n3. So n2 into cos 15 minus mu sin 15 plus n3 into cos 60 minus mu sin 60 is equal to 1000. So on solving this, 0.914 n2 plus 0.326 n3 is equal to 1000. This is the another relation. So initially we have made a relation between n2 and n3. So substitute this n3 in terms of n2 here. So we will get 0.914 n2 plus 0.326 into 0.452 n2 all divided by 0.966. So we will get n2 is equal to 1000 divided by 1.066, which is approximately equal to 938.08 Newton. So we got n2. Then we can go to the equation number P and we can substitute n1 in terms of n2 using this equation. So P is equal to 0.2 into 0.914 n2, which means n1, plus 0.452 n2, which is equal to 0.6348 n2, and n2 is this one. So by multiplying these two, we will get P is equal to 595.49 Newton, which is equal to 595 Newton. I hope the problem is clear to you. If any kind of doubt, you can ask in the comment section. Thank you.